I ask a quick question? Are we talking about the whole pH storage right now because of like people recovering RNA and DNA from like dinosaur fossils? Like, why are we talking about the storage conditions? I guess.
Yeah, they are recovering it from dinosaurs. That's a good point.
Well, well,
I,
also,
I
I don't
guess
know.
like
I
is
don't know.
that like proof that if they can recover RNA and DNA from dinosaurs, is that like going against the prompt? I guess essentially is that what you're arguing that it'd be destroyed and there's no way to recover it?
I think he's just saying that RNA is really unstable. So
Well,
if we're
if
saying that was a precursor to DNA and somehow gave birth to cellular life, that would be problematic because it would be destroyed by the environment. But
well, let me
also,
make my
we're
let me make
but
my
we're
claim very clear that yes, if they're finding it in dinosaur bones that's 65 million years old, or they're finding it in bacteria that's 250 million years old, we understand the DNA half-life, and the fact that they're finding it in dinosaurs and in 250 million year old bacteria. Then my claim is exactly that it can't last that long, and that would prove a young Earth, meaning that the dinosaur is more than likely unalived in the flood 6,500 years ago, according to the Bible, and not 65 million years ago.
I mean, in the
yeah,
right
I mean,
conditions, though, the DNA and RNA could last that long. Not necessarily in like a usable form, but in like a fossilized form that we could tell the structure of.
Sure, give me the
yeah.
mechanism that protects it or gets it out to 65 million.
Are you
Extremely
talking about like
cold and
the
dry conditions will fossilize it.
Well, that's
and
not
there's a are you talking about the soft tissue in the
brother.
T
Just
Rex?
yes, that too. And no, it won't. It doesn't go out to 65 million years.
Not to be workable, but I mean to be readable, you could read the structure. It's not
No,
like it's not intact, no, but it's
no, it
fossilized.
doesn't say it, but it's not fossilized because you still have the chemical markers that still attach to it. And in the 250 million year old, they were actually able to revive the entire bacteria. So it's still absolutely readable and workable
They
because the
revived it,
bacteria.
but they probably like resequenced it and cloned it. They didn't like
No,
revive the actual
no, they
DNA from the
revive.
thing.
Yep, they absolutely revived the actual DNA. I can give you the source
What?
material. Yep.
No,
They
hold
didn't
on.
use
From
PCR at
my
all. They didn't like amplify the DNA at all.
Well, according to them, what they did is they looked at the salt layer, and it was like 1,000 foot down, and it was supposed to be in a salt layer that's 250 million years old. They brought up the salt crystal that had some of the prebiotic ocean with encapsed in one of the salt crystal bubbles, if you will. Still had the ocean within it. They took that out, put that inside of a petri dish, and it started to grow, showing that the bacteria that was inside of it had to be 250 million years old if you go with evolution or the geologic column. Now, clearly, I don't grant that. I think that this happened during the flood 6,500 years ago, and that's why you're still able to revive the bacteria.
Yeah, I
I'm
could see like the timing could be wrong. Like our ways of telling how old things are could be flawed. They talk about like carbon 14 dating being like a flawed mechanism of like it's
Yeah.
not really indicative of like when something was. There's multiple factors that could change those ratios.
All your
am I
radiometric techniques are
hallucinating here?
wrong.
But what I'm hearing is that RNA or DNA was magnified or found from dinosaur fossils. Is that what I'm hearing?
Yeah.
Uh, wh- this is the first time I've ever heard that.
Yeah, so
Well,
there was a T-Rex where they found soft tissue inside of it, but the people who made the discovery also wrote a paper talking about a chemical method to preserve that soft tissue. I didn't know that they're claiming to have
yeah.
recovered like
So hold on.
fragments
Let's
of DNA or
This is
RNA from
why
there.
this is why I want to do one at a time because you say so much stuff. So yes, they did find the soft tissue. That's not what I'm talking about. You said in the soft tissue paper that they come up with models to get it out longer. That's factually inaccurate. Go to the papers. There's been two. Both of the papers literally say this is not the mechanism. The very first words of Mary Schweitzer's iron in the blood study, which you're bringing up right now, which is chemical cross-linking, iron cross-linking. That's what you're bringing up right now. The very first words of the abstract state that the persistence of soft tissue in Mesozoic fossils is not explained by our current degradation models. The second paper says we have no method to get this excellent preservation. So when you're saying things like that, that's why I want to attack that because you're putting so much stuff out there that we're going back and forth. But the chemical rate to get it to go to 65 million years, according to the paper that you're citing, says this is not the method. I can take you there if you want. There's another paper. This is also done by Mary Schweitzer. The name of this paper is called "Evidence of Proteins and Chromosomes and Chemical Markers of DNA in Exquisitely Preserved Dinosaur Cartilage." This was done in 2020. That's the name of the paper. What they did is they took two chemicals. You guys might know more about the chemicals than I do, but it's called DAPI and propidium isolate, PI. Evidently, these two chemicals react to they bond to the curved helix structure of DNA. So what they did is they went to the nucleus of this what they considered to be they thought was a dinosaur cell, clearly in the soft tissue. They said, okay, this looks like a dinosaur cell, and I would love to. I'm giving you all the information because I can't turn the camera around because literally Google or I'm sorry, TikTok bans me. That's why I'm giving you all the thing. They got pictures of a cell dividing. They got pictures of the what they consider to be the nucleus where the DNA is housed, and they put these two chemicals in there. They're supposed to react to DNA, and guess what? They reacted. And it literally says in the paper that it has to. These are not supports compound within the cells, chemically considered with DNA. That the material is double-stranded and has a minimum length of 6 base pairs. So it has to be, that means it's readable, at least by 6 base pairs. Probably not a lot, I'm not saying that, but it's still clearly connected, it's still double-stranded, and it has at least 6 base pairs. So that's DNA, my friends.
Well, no, this is
Can I read a line from the
protein.
first paper?
This is collagen protein, just for the record. This has nothing to do with DNA or RNA.
Which paper are you looking at? Because I just gave you 2. So are you talking about the one that I just cited, the evidence of proteins, chromosomes, and chemical markers of DNA? Is that because that's clearly DNA? When it says DNA, I believe it's DNA.
Is that the 2020 paper?
That's the 2020 paper. Evidence, and this is the name of the paper, evidence of proteins, chromosomes, and chemical markers of DNA in exquisitely preserved dinosaur cartilage, 2020.
No, I'm talking about the one from 2005 in Science.
Okay,
that's 68 million year old dinosaur
that's different. So we're talking about 2 different things. So that's why I didn't want a shotgun. So the DNA chemicals or the DNA markers was found in 2020. Same scientist, Mary Schweitzer. But if you want to go back to the dinosaur collagen, yes, I never claimed that they're finding DNA in that one. That one they're finding collagen, which is endogenous to the dinosaur. And again, we know what the half-lives are collagen is. And read the very first words of the abstract. It literally tells you that if you read the iron cross-linking one, it literally says this is not the mechanism to get it out to 65 million years.
Wait, I'm confused because it says, I'm reading it. It says we hypothesize that this exceptional cellular preservation extended to the molecular level and had molecular features in common with extant avian cartilage.
Yeah, okay. So you're reading the evidence of proteins and chemicals, which in the DNA. Is that the one you're reading?
Yeah, the 2020 abstract.
Right. Yes. But so which one are you going with? Are you going with the iron cross-linking? Because that's a separate paper, brother. That's right. We're getting confused because we're going to 2 different places.
Yeah, I'm confused because it sounded like you said both papers deny that they have come up with an idea about how this preservation could have happened.
No,
but in both of them, they literally say, like in the 2006 one, it says a 2-part mechanism involving first cross-linking of molecular components and subsequent mineralization is proposed to explain the surprising presence of still soft elements in fossil bone. That's in 2005.
Yeah, it's proposed, but it's not that. That's it. If you go to the very first paper that she did with the soft tissue, the name of it is where's it at?
Soft tissue and cellular preservation in vertebrate skeletal elements.
No, not that one. She did one in soft tissue. A role iron and oxygen chemistry play in preserving soft tissue cells in molecules from deep time.
Can I share the exact quote from that 2020 paper? It says, quote, "We caution that only the sequencing of the material reactive to both PI and DAPI can confirm that it is dinosaurian in origin." This is basically saying that they can't confirm that it's dinosaur DNA without sequencing.
No. We caution that only sequencing of the material reactive in both PI and DAPI can confirm that it is dinosaur in origin. Yeah, they're saying
but they're saying that they can't confirm that it's actual dinosaur DNA without sequencing.
No, if you actually so they haven't sequenced it, yes, and they're being cautious, no doubt. But if you continue to read on down,
it's not confirmed.
Okay,
that's the point.
Continue to read on down in the conclusion. Contamination is not plausible. They're sitting there telling you that this is not contamination. They literally go on to tell you that there's no contamination. So what DNA sequence could it be for if there's no contamination?
How could contamination not be plausible, though? I mean, it's always plausible.
That's what the conclusion is. Go to the paper right there. Like I said, I really wish I could turn
And like
this around.
6 base pairs, like how would they determine that that's not contamination and from the sample
That's
if
what
it's
go
just
to
6 base pairs?
you read the paper, so continue it on down. It's if you go to the conclusion, it's 1, 2, 3, 4. It's
I have
on
it here.
fourth paragraph. And in the middle of it, it starts. Contamination is not a plausible explanation in this case, and to this day, a plausible preservation of original proteins and DNA in deep time has not been conservatively estimated with data. So they're telling you that I mean, I don't think nobody is ruling.
How would a fossil not be
says anything.
contaminated, though? I mean, where do you find a fossil? It's surrounded by contamination when you find it. So I don't understand how you'd free a sample of contamination.
It's what the paper says, brother. It's not.
Yeah,
I was talking to the
say
guy that's in the chat. I'm agreeing with you on that part. You know that seems pretty ridiculous.
Well, probably
one thing
I would
about the
say that
bacteria,
the sample
though, is
was
that
isolated inside the material, inside the bone.
Yeah.
and there's no way that contamination can penetrate a bone when it's been buried that long.
Well,
I mean, they're just saying. I don't know. The paper's saying it's not plausible.
Let me tell you why I don't think it would be. I don't think anything should be absolutes. I would agree with that. I think you should use caution and not make absolutes. But when you go to a cell that you consider to be endogenous to the dinosaur, you find a quote unquote fossilized cell. You go to the nucleus of that cell where the DNA is housed, and then you find DNA in it, and then you say, well, it has to be contaminants from something. So now I have to believe that some other DNA went in and contaminated the nucleus of a dinosaur cell. That doesn't make any sense. So is it possible? Yes. Is it probable? Very, very, very not probable. I would have to believe that something else invaded the nucleus of a dinosaur fossil and then injected its own DNA in there. I think that's very implausible. I think the evidence that we should go with is clearly that this is dinosaur DNA.
I want to read the conclusion, though, to just go against what you seem to be absolute in that this is conclusive DNA. It says, quote, the identification of chemical markers of DNA. That's important. The identification of chemical markers of DNA in this Hippochrysaurus suggests that it may preserve much longer than originally proposed. Our data suggests the preserved nuclear material in this Hippochrysaurus was in a condensed state at the time of death of the organism. This quote, chemical markers of DNA, basically says that it's not DNA itself. So again, this paper does not conclusively state that it is DNA or RNA, and that's what I want to hammer home.
We propose that you stopped reading right there for some reason. If you continue to read, it says we propose that the DNA condition may be favorable process to its fossilization. So
I'm saying they found DNA.
Right. So they say that the DNA is not, it's literally exactly what they're saying.
No, it's not.
They're saying chemical markers of DNA.
Fine. I want you to continue to read what you just read then. You stopped right there for some reason. Continue reading. You only got 2 more lines.
Well, it's the relevant quote. So, I mean.
Yeah, we're going to stop. We propose that the DNA, what does that mean? If it says that we're not finding DNA, then why does it say DNA right there?
I'm confused as to why you're arguing for finding dinosaur DNA in the fossils, though. You know, like I thought, like are they not millions of years old? Are they saying that
we got the half-life of DNA. DNA cannot last 65 million years old.
Host, do you want me to read the whole conclusion?
No, you can read. No, I just want to know why he stopped at the word DNA.
Well, we can get the whole quote.
But the first sentence says identification of chemical markers of DNA.
Right. Yeah. No. Look. I'm not adding to what the paper says. My conclusion is different than Mary Schweitzer's. Mary Schweitzer's not a young Earth creationist. You guys need to understand that. Like, me and her's not going to agree on a lot. And they're being cautious and haven't announced that it's DNA. I can clearly read to this paper and I can say that clearly this is DNA. Now they're calling it DNA markers, but they also are referring to this as DNA. They clearly are. But if you want to say, have they announced DNA? No, they haven't. But I don't need her to announce that for me to read her paper and see that these chemical markers that attach to DNA that's found in the nucleus of a cell is come on, man, it's DNA. You take chemicals that react to DNA that light up like in a black light with DNA. That's not what it does, but just to make so everybody else can follow. If I put this chemical that reacts to DNA only, and it has to be at least 6 strands for the chemicals to even be able to attach to it. It has to be double-stranded in helix in nature. That's DNA. I go to the nucleus of a dinosaur that's endogenous to the dinosaur. I ruled out contamination. I squirt the chemicals in there and I get the reaction. What is it? You have to come up, even though I don't care if Mary Schweitzer's not announcing it or not, you have to now tell me what is the probability of it not being DNA, because it's clearly DNA. And we ain't even got to the paper where they revived the 250 million year old. But so, long story short, I don't need her to agree with me. I can read her paper and determine for myself that that's clearly DNA. I can
Here's the other
preservation technique.
Here's the other part of the.
Go ahead.
Here's the other part of the conclusion. I just want to be complete. It says, although extensive research and sequencing is required to further understand DNA preservation in Mesozoic material, along with its chemical and molecular alterations, our data suggests the preserved nuclear material in the Hydrochosaurus was in a condensed state at the time of the unaliving of the organism, which may have contributed to its stability. We propose that DNA condensation may be a favorable process to its fossilization. And further, it says contamination is not a plausible explanation in this case, and to this date, the possible preservation of original proteins and DNA in deep time has not been convincingly eliminated with this data. So again, this is just a long-winded way of saying this is inconclusive and not DNA necessarily.
So you read the end of the conclusion, and then you went back up to make it sound like that was the end of the conclusion.
Well, actually, I meant to start earlier in the paragraph of the conclusion, right. But it doesn't matter. It's the point of the conclusion, which is that this is inconclusive. Conclusion equals inconclusive.
Yeah. So what it says right here, it says the contamination is not a plausible explanation in this case. So they're saying that that we didn't have any contaminations. What they're saying, it's not plausible. And to this date, no plausible preservation of original proteins and DNA in deep time have been conservatively estimated with data. That is saying, you're misrepresenting what it's saying. It's saying that this is DNA and we don't have the method to explain it. That's exactly what that is saying. And you read it out of order.
They don't have the method to prove it.
No, brother, I don't. How are you coming to that conclusion? It's right here.
Because it says it. I read it.
Okay, so let's read it again. Contamination is not plausible, right? Contamination is not plausible.
Oh no, man.
Explanation in this case. And to this date, a plausible preservation of original dinosaur DNA in deep time has not been convincingly eliminated with data. So what is that saying? And he left. Yeah, you left. You flipping coward. You come up here, you read the conclusion out of order in an effort to make it look to strengthen your case, but you didn't know that I was following along with you reading the conclusion. So you got to the end of the conclusion and then you went back up and ran the beginning of it. But it doesn't fit what you said. It's literally saying that we're finding DNA and we don't know the method that gets it out to 65 million years. You're being dishonest. It's exactly what that says.
I just want to say I offered to read the whole paragraph for you.
You did, but I was trying to get, and I didn't know that he was going to be dishonest like that. I seen him stop at DNA, and I was like, just continue reading because you're claiming they're not finding DNA. If I realized that he was going to be dishonest like that, brother, I'd have had you read the whole thing, but I didn't think we needed to. I didn't think that he was going to try to pick and choose. Now,
I mean, whether the dinosaur DNA is 1 million years old or 65 million years old, I mean, wouldn't 1 million years old still be an issue for the prompt? Because in permafrost, it can last up to 1 million years to 1.5 million.
Sure. Why would that be an issue for me?
Well, I guess like what's the deal between 65 million and 1 million? What's the big difference?
64 million years.
I mean, we could be wrong in terms of the timing, but I mean, the 1 million is like that would still be, say, dinosaurs were 1 million years ago instead of 65 million years ago.
No,
how does that change anything about the prompt?
All right, so I got you. What changes it is I could say that Noah's flood happened 4,400 years ago. All of these dinosaur bone beds that you see were they unalived in the flood. They floated around rotting for 4 months, and then as the waters receded, they got set down in these huge graveyards, and then sediment washed over them, fossilizing them. Because this was 4,500 years ago, I can make some predictions. My predictions would be that we can still find dinosaur soft tissue and we can still find DNA fragments within them because they're only 4,500 years old. Your theory, not necessarily your theory, I don't know what you believe, but if you're an evolutionist, you can't make that claim. We know what the degradation rates of collagen is. We know what the degradation rates of DNA is. You cannot say that it lasts for 65 million years. You're stuck. I'm not. That's why it fits my theory, not yours.
They ask me where it started. I point you dust and breath. Not chancing the blank canvas, but hands that shake the earth. You call it all a stumble, I call it written truth. From Eden to the waters, he kept his word in view. Creation to the floodline, the same God held it all. You brought a stack of theories, I brought the living cause. You can test me with the evidence, I stand on every line. If the book says it, I say it every time, every time. God made it, God made it. That flood was real,
I'm still saying it.
God made it, God made it. From dust to the deep,
I'm still saying it.
still saying it,
Still saying it. Still saying it.
still saying it. You talk AB of Genesis, I talk blood and breath. Life does not write itself up from nothing and then rest. You say bones are just so bones, I see order in the frame. Dinosaur dust and DNA still calling on his name. I seen the doubt get louder, I've seen it come and go, but every age keeps asking what only God can know. You can test me with the evidence, I stand on every line. If the book says it, I say it every time, every time. God made it, God made it. That flood was real,
I'm still saying it.
God made it, God made it. From dust to the deep,
I'm still saying it.
still saying it.
Still saying it. Still saying it.
You're hidden behind the keyboard, hiding behind the screen, trolling the comment section, tearing down things unseen. But if